Hello everyone, welcome to Science and online classes. In the previous classes, we were discussing the problems on the graphs. Today also, we can solve some more problems on the graph. In this class, see the question. The following data are number of girls to the nearest 10 per 1000 boys in different sections of Indian society is given below. Here, sections are the scheduled caste, SC, scheduled tribes, ST, non-SC and ST, backward districts, non-backward districts, and rural section and urban section. In this, number of girls per 1000 boys is given here. We should draw the bar graph of this data given. Represent the information given here by bar graph. Now first, we should draw the bar graph of this one. First, y-axis and x-axis. X-axis you can take the sections. Y-axis you can take number of girls. Number of girls per 1000 boys. Per 1000 boys. Here the lowest value is 910. The highest value is the 950. You can take the scale as y-axis. What is here? 1 centimeter equal to 1 centimeter equal to 100 girls. In this one, 100, 200, 300, 400, 500, 600, 700, 900, 1000. 1000 we are taking here. Now first one is SC. In this SC, 100, 200, 300, 400, 500, 600, 700, 800, 900, 1000. Now here SC is given 940. 940 means you should draw this 940. The number of girls in SC section is 940. Next, the number of girls in ST section is 970. Number of girls in SC section is 970. It's a little more than the SC. The number of girls in non-SC it is 920. 920. What is here? ST, non-SC, ST. The next one is backward districts. The number of girls in backward districts is 950. This is little important that one. 950. Draw this bar graph. Next, the number of non-backward districts. The number of girls in non-backward districts is 920. Here also 920. Next, here also the non-SST girls are 920. Here the first one, this one, backward districts, non-backward districts. Next one is rural. The rural is given how much? 930. This is 930 rural value. Number of girls in rural area, rural section. The number of girls in the urban section, it is given 910. Urban section, it is given 910. Now observe here, there is very slight variation in the number of girls in this one. The highest value is 970. 970 is the highest value. Now next, what are the conclusions on the graph here? The highest number of girls is in ST section. The highest number of girls is in ST section. The lowest number of girls is in the urban section. Highest number of girls is in highest number of girls or more number of girls in more number of girls are in which one? ST section. ST section, and less number of girls are in urban section. First, what we are doing here, the number of sections are given here, number of girls in each section they have given. X-axis we are taking the sections. Y-axis we are taking the number of girls. The number of girls start from 0 to 1000 we have taken. Each 1 centimeter equal to 100 girls. Therefore, in SC section 940 girls are there. In ST section 970 girls are there. In non-ST section 920 girls are there. In backward districts 950 girls are there. Non-backward districts 920 girls are there. Rural areas 930 girls are there. Urban areas 910 girls are there for 1000 boys. In this one, highest value is ST section. In this one, highest ratio of the girls is given. In the lowest ratio of the girls is given in urban areas, urban section. This is the required graph. Now, the next question we observe here. Given below are the seats won by different political parties in polling outcomes of a state assembly election. Here, political parties are given and the seats, number of seats won by the political parties are given. Party A won 75 seats, B party won 55 seats, C party won 37 seats, D party won 29 seats, E party won 10 seats, F party won 37 seats. First question is, draw the bar graph to represent polling results. Second question is, which political party won the maximum number of seats? Now, first let us draw the bar graph of these polling results. First one is x-axis. We can take x-axis. We can take the political parties. axis we can take the number of seeds 1. Seeds 1. Here the lowest value is 10, the highest value is 75. Therefore, we can take the scale as y-axis. Scale y-axis equal to y-axis is 1 centimeter equal to 10 seeds. 1 centimeter equal to 10 seeds. You can take the scale. Now, first one is party A. A party 1, 75 seeds. Now, first write the y-axis. The scale here 10, 20, 30, 40, 50, 60, 70, 80, 90, 100, 110. 10, 20, 30, 40, 50, 60, 70, 80, 90, 100, 110. First, party A1, 75 seeds. In this one, 75 seeds you can mark here. In between 70 and 80. Party A1, 75 seeds. Next, party B1, 55 seeds. B party 1, 55 seeds. Seeds between 50 and 60. Seeds. Party B1, 55 seeds. Next, party C1, 37 seeds. Party C1, 37 seeds. Near to the 40. Seeds. Next, party D1, 29 seeds. Party D1, 29 seeds. 29 seeds is near to 30. Yes, if we parallel this one, 29 seeds. Party E1, the 10 seeds. Party E1, the 10 seeds. Party F1, the 37 seeds. Party F1, 37 seeds. Now these are the bar graph representing the number of seats won by the each political party. Here A party 1, 75 seats, B party 1, 55 seats, C party 1, 37 seats, D party 1, 29 seats, E party 1, 10 seats, F party 1, 37 seats. The next question is, which political party won maximum number of seats? Observe this graph. Highest value is 75. The longest bar in this graph is party A. Party 1, highest number of seats, maximum number of seats. Maximum number of seats. In this all parties, A party won the maximum number of seats. That is the graph. In the next question, you observe here the length of 40 leaves of a plant are measured correct to the 1 millimeter, and the obtained data is represented in the following table. They have given length of the leaves in millimeters and number of leaves they have given. First, we should write the continuous class interval of a given interval information. Here 180 to 126, but here 126 number is not there. That is why we make this class interval continuous first. First, we will make the class interval continuous, then we can write the graph. For this first question, draw histogram to represent the data. To draw a histogram, we need continuous class interval. That is why we will write this continuous class interval. 117.5 to 120.56. Here, for lower limit, we will subtract 0.5. For upper limit, we will have 0.5. In this one, like this, we will write the continuous data. First, draw the histogram to represent the data. First, draw x-axis and y-axis. This one. And here, the length will write here. Length of leaves. And y-axis, number of leaves. Y-axis is number of leaves. Now here, the length of leaves is start from 117.5. 117.5. Next is 126.5. 126.5. Next 135.5. 135.5. 144.5. Next 153.5. Next one is 162.5. Next is 171.5. 171.5. These are the length of leaves in millimeter. Length of leaves in millimeter. Y-axis, number of leaves. The lowest value is 3. The highest value is 12. We can take 1, 2, 3 here. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. 1, 2, 3, 4, 5, 6, 8, 9, 10, 11, 12. In this one, the first one is, what is first one? From 117.5 to 126, the number of leaves are 3. Now here, 117.5 to 176 here, number of leaves are 3. Stay here, number of leaves equal to exactly 3. 126 to 135, number of leaves are 5. 126 to 135, this class interval. In histogram, the data is represented continuously. There is no gap between the bars. The data are continuous. That is why we should take the graph continuously. It is 5. It is here. Extend this line. 5. Join this. Next, what is here? 135 to 144. Here 135 to 144, how much is given? 9 is given. Extend up to 9 here. Next, 144.5 to 153. 144.153. How much is given? 12 is given. Extend here. this one up to 12. Next, 153 to 162. 153 to 162. The number of leaves is 5. 5 is here. Join this one. Next, 162 to 171. 162 to 171 is 4 number of leaves are 4. 4 here. Join this one. Next, from 171 to 171 to 181.5. 171.5 to 181.5. 181.5. Here, the number of leaves is 2. It is 2. It is equal to 2 only. Take this length, approximate. This is the histogram represented. In a bar graph, the gaps will be there between the bars. Here, there is no gap between the bars here. This is called histogram of the given data. First question is, draw the histogram to represent the data. This data is represented in the form of histogram. Here, 117 to 126, 3 leaves are there. 126 to 135.5, 5 leaves are there. 135.5 to 144. Here 9 leaves are there. 144 to 153. 12 leaves are there. 153 to 162.5. 5 leaves are there. 162 to 171.5. 4 leaves are there. 171 to 181. How many? 2 leaves are there. This is the way to represent the given data in form of histogram. Is there any other suitable graphical representation for the same data? Same data we can write in the frequency polygon. We can use a frequency polygon to represent the same data. How will you draw the frequency polygon? We should just mark the midpoint of the given data. Midpoint of this information histogram, we will get a frequency polygon. Join this. If we join the midpoints, we will get a frequency polygon. This is called frequency polygon. We can represent the same data by frequency polygon by joining the points here. This is the next. Is it correct to conclude that maximum number of leaves are 153 centimeter? No. The data is from 153 is there now. 153 centimeter. The maximum frequency is from 144 to 153. It is given. The maximum number of leaves are from 145 to 153. Okay? It is not exactly only 153 millimeter. We cannot take it here. No. The number of leaves from 145 centimeter to 153. In this interval 12 leaves are there. Okay? Only in this interval, not exactly 153 centimeter. This is the way to represent the given data in form of histogram.